Decorators towards the very end of this. If you have questions or comments, don't hesitate. Anytime is a great time for questions. Just raise your voice, draw my attention, ask your questions or comment. I'll be delighted to hear what you have to say. Let's talk about what we did with JavaScript in the past. Well, JavaScript is a language that is both functional and object-oriented. It's been that way ever since its time of creation. But how did we create functions in JavaScript? Well, the way we created functions in JavaScript is you put the word function, and then you call it whatever you want to call that function as. For example, greet, if you want to call it greet. And I can give a name to this function. Of course, in this case, I can simply say something like greet, and then I could say hello, for example. And then we could specify whatever the value that I want to display in this case. So I could say greet, for example, Joe, and in this case, I'm calling the function called greet. But what about creating classes? How did we define classes in JavaScript in the past? Well, the way we defined functions in JavaScript is, you would say classes in JavaScript is you would say class, for example, car, and then within this you would say, for example, something like created. And of course, if you look at this, I would say we created a class called car. I know what you're saying. You're saying, wait a minute, you didn't create a class called car, you created a function called car. No, trust me, we created a class called car. How do I say it? Did you notice that uppercase C over there? That's how you know it. So in other words, JavaScript merely used an unfortunate convention. And of course, when it's a convention, how do you really use an object of this car? So to do this, you would have said car equal to new car like this. And then of course, you can print out the object of car. Now, as you can see there, it created an object of car. But you may look at this and say, oh, darn it, but what if I had called the function car like this? And as you can see, that call created. Now that's pretty confusing, isn't it? Did you mean to use this as a function? Did you mean to use it as a class? Well, clearly I meant it to use it as a class. Well, how do I then enforce that you used it as a class? You know, most JavaScript programmers never did this. And a lot of JavaScript programmers didn't even know this. But it turns out, you can come in here and you can ask for new.target. And when you look at the new.target, that's kind of weird, isn't it? The new target is actually a square bracket function colon car when you used new car to run it. And the same thing is undefined when you used it as a function. That sadly is the way JavaScript knew whether you are using a function as a function or whether you were using a function as a class. Do you think that's very kludgy, right? It's not very much fun to do something like this, very difficult to maintain and really hard to work with. So JavaScript was a complete mess in that regard. And then of course, if you were to come in here and ask the question, what is car? It is actually a function car. And then that's like, gosh, is it a function or a class? And there was no real classes in JavaScript. They were just functions at the end of the day. So this led to a lot of confusion. And this confusion only became worse as time went on, because we had to know how to create functions within classes. But if a class itself is a function, where do you put the function that belongs to a function? And this just took those down the path. And what did people do normally to deal with this? Well, they decided to use libraries. And the libraries took care of doing these things. So developers don't have to fight this. They gave this to a library. But that only made things even worse, because now you have to use a library of functions to deal with these things, which adds up a lot more effort on it. So JavaScript decided to step back and remove all these messy code. And they said, what if we really make it clearer? What if we make it easy to understand, easy to write, easy to work with? So moving forward, you can actually create classes in JavaScript. So how do we create a class in JavaScript? You use the keyword called class, and you say class car, and that's your class called car. And I can simply create an object of this. For example, constant car equal to new car. And then of course I can print that car object here. Now obviously the question is, if car is a class, then is it true that now JavaScript has a class? Now this is one thing you have to keep in mind, because one of the things I care about a lot is not just learning the syntax. Syntax is the least interesting thing, because you learn syntax by doing it over and over and over. And then one day you don't have to think about it, you just type it. But what is extremely important when learning a programming language is not to pay attention to the syntax, because that kind of comes natural when you get practice. What you don't see in the code is the semantics, because the semantics is hidden behind the syntax. And developers who don't learn the semantics will fall into trap, because they will learn the syntax, but when the code behaves different than what they thought about, they'll be very surprised about it. So one of the things you need to keep in mind is JavaScript has introduced newer syntax, but the semantics of the language is as much as it was in the past. It did not change at all. So if you ask the question, what is really a class called car, you will notice it is still a function. So notice it didn't change at all. It didn't tell you that car is a class, it's still a function. Now, obvious question then is, if it's still a function, then can I call it as a function? Now, just think about this for a minute. If I had written the code the correct way, what would I have done in the older syntax? In the older syntax, I would have said function uppercase C car, and within the function I would have said if new.target is null or undefined rather, then blow up and tell the developer, how dare you call me as a function? I was supposed to be a class. That's what you would have done, isn't it? Well, if you could do it, guess what? They could do it too. So when you run this code, it blows up on your face. And it tells you class constructor car cannot be invoked without new. So what is the magic? You know the rest of the story now. All that they do is when you write this syntax, they write the function for you behind the scene. And within that function, they check to see if new.target is undefined, and if it is undefined, they blow up, because it was supposed to be used as a class and not as a function. So that's basically what it is. So the moral of the story is, semantically, it's the old stuff. Syntactically, it's the new stuff. There's a phrase in English for this. It's called putting a lipstick on a pig, right? So that's what we really have. It's a beautiful pig. I'm not saying the pig is not beautiful, but it's got a new lipstick on it, right? So it's a new syntax, but the old semantics, that's what you're dealing with. But nevertheless, it makes life a lot easier. So how do we create a constructor for the class? Now, before we go further, there is one thing you need to keep in mind. JavaScript does not have function overloading. Now, I mentioned this in a conference. I'm not even kidding with you. I'm not making this up. And I suddenly heard a thud in the room. I stopped and looked at this developer, and he said, I wish I had known this. And I'm like, what do you mean? He said, I thought JavaScript had function overloading, and now I know why my code did not work. So this is a discovery we sometimes make, right? So it's very profound. So you need to keep in mind, JavaScript has no concept of function overloading. If you're writing code in language like Java, you can write multiple constructors. You can't do that in JavaScript. You can only have one constructor. But how do you write a constructor? I do have to say I actually like it. So if you want to write a constructor in this case, you can go into the class and you say constructor right in there. And I like it because you want to write a constructor, you write a constructor. In languages like Java, the name of the constructor is the same as the name of the class, and I can tell you how many times the beginners have trouble with it. And then they try to put a public void in front of it, it's a mess after that. Well, JavaScript makes it cleaner. You want to write a constructor, write a constructor. And within the constructor, I'm going to simply say created right there, and when I run the code, you can see it says created. So this is how easy it is to create a constructor in JavaScript. Of course, I want to send the year for this car, so I'm going to say year, and within this, of course, I can simply say this dot year equal to year, and of course, when I run this code, I can pass the year to this, and then of course, I can come back and print the car. You can see it's got the year property sitting inside of that, and that displays the information for us for the car. So that gives us an idea about how we can write a constructor for the car and we can use it. But what about defining fields within a class? Well, if you want to define a field within a class, you don't have to really do anything special in the case of JavaScript. Now, this is something you need to keep in mind. JavaScript is a dynamically typed language, but it's also a very dynamic language. What does that really mean, a dynamic language? Now, if you really think about it, in the world we live in, we're all humans, right? Absolutely. But there are things that some of us have, others don't. For example, some people have long hair, beautiful long hair, but I don't have a beautiful long hair like Scott does. Now, it doesn't mean, imagine if you are programming in Java. Everyone in this room will have a long hair, right? Because Java says if Scott can have long hair, everybody should have long hair. I don't know about you though. I'm not a big fan of having long hair. I love Scott's long hair. I cannot tell you how many times in airports I see this wonderful person with long hair and I go hug and say, hello Scott, and this lady turns around and says, what? And I'm like, I'm so sorry, right? So absolutely. But in the case of JavaScript, every single object can be different. And that is the fun part. Some objects have mustache, some don't. And that's a choice for you. You're not forced to have all these parameters for all the objects. And it's really dynamic. Oh, let's see how that is in just a minute. So in this case, of course, just as an example, if you want to look at it, I can say, for instance, I can say drive here. We'll come back to functions in just a minute. I'm going to say miles equal to 0 as a silly example right here. When I run it, notice it only has a year as a value. But if I say car.drive and then I print the car, what is it going to do at this point when, okay, derive, always in math, sorry, drive. Okay, so, yeah, don't drive. So right there, did you notice how it acquired the miles property at a later time? And this is exactly the point, right? Objects can acquire properties, objects can relinquish properties. That's called dynamic. So objects are truly dynamic. You can create 7 objects of car, and some may have some properties, others may not have other properties, and you can go back and forth with it. So that's very easy to create, if you will, and you can add things to it as and when you want to. So that gives you a nice benefit to work with these dynamic behavior. But getting back to this, how do we really define a field? Well, if you want to define a field, I'm going to say this dot miles is equal to 0. Or for those fans, if you want to say kilometers, you can say kilometers equal to 0, right? So in this case, my car has 2 properties, year value and a kilometer. This car has not been driven yet, so as you can see, that's the field. So you don't define fields like in the case of Java. Now that may, you know why you don't, right? Because of the fact I just mentioned, classes are dynamic, objects are dynamic. In the case of Java, you tell every single object should have all these properties. It's an all or nothing proposition. Not so in JavaScript. JavaScript says, as you go, you can acquire properties, you can relinquish properties, and that's why you don't have this boilerplate to define a list of properties in the top, because that would be so boring to say everything it can have, because objects don't have all the properties all the time. So this gives you that flexibility. You just define them wherever you want to, typically in a constructor, but also in other methods you can initialize them as well if that's where you want to really do it. So this shows you how to define a property, which is a field rather, and of course you can define methods in classes as well. So how do I define a method in class? Now, for those of you who joined us after I started, I was mentioning one thing earlier, and I want to kind of remind you about that, and that is JavaScript has a newer syntax for classes, but the semantics is exactly the same as it was before. So if you knew JavaScript really well before, it is behaving exactly like the way it did. If you did not know JavaScript before, it is still behaving exactly the same as it did. So that didn't change at all, right? So that's basically how JavaScript is. It is as wild as it was, except that it's just been tamed with the better syntax on top of it. Which means, how do you define functions in JavaScript in the past? Well, in the past, you didn't put functions in functions, you put functions in what are called prototypes. So what is a prototype? A prototype, think of a prototype as a bag, just now, right? So think of it as a bag. And you put all this in the bag, and objects can share this prototype. I'm going to come back to that a little bit later. But when you define classes, you put functions into prototype. This was a total nightmare in JavaScript, because you wrote functions for classes, and then you said car.prototype dot, and you added method to it. And this was a confusion. People were not sure, do I put it in the function, do I put it in the class, do I put it in the prototype? You know what, don't worry about it. They streamlined it. So what did they do? Notice that in this case I can say drive, and I'm going to say distance, and this is going to be, all I'm going to do here is this dot kilometers plus equal to distance. So we wrote a function called drive on the car. That's what we did. So now what am I going to do? If you notice over here, when I run this code, you can see it said year is 2019, km is 0, but I'm going to say car.drive 10, and I'm going to print the car, and you can see that it's got kilometers is 10. But you know, I'm a person who is very curious. I don't write code and I'm saying it works. The minute the code works, I break it. And I want to see why it works. And I want to put it back together. And this is one of the things where, you know, you sit there and keep coding, and you know what, you think will take 20 minutes and it ends up taking 4 hours. And you are very happy. The boss usually is not. But you're like, this is awesome. I know how this works. And the boss is like, are you done yet? And they're like, this is beautiful, right? And I want to tear this apart a little bit. So what I'm going to do here for you is to say constant. Let's go ahead and say over here car2, and we'll make it car1 equal to new car, and we will say this is 2019. Doesn't matter, the year doesn't matter really. But what I'm going to ask you here is, I'm going to ask the question, is it true that car1.drive is exactly the same as car2.drive? You know what this triple equals means in JavaScript? It means that you're performing an exact comparison, not a converted comparison, right? So I'm asking, are the car's functions exactly the same? Before I run this code, notice we defined this within the car right in there. That's what we did. But when you run this code, it says true, which is a good news, isn't it? Because raise your hand if you think every object should have its own function. Yeah, nobody raised the hand, right? And the reason is, you know, that's not efficient, because if you create 10,000 objects, you're going to copy the function 10,000 times. Nobody wants that. Well, so what happened? Again, remember the syntax versus the semantics. That's very important. So if you ask the question car.prototype.drive, and notice that's where it's sitting nicely. And if you ask the question, if that is equal to car1.drive, notice that is true. So car doesn't have, the object of car doesn't have functions at all. When you define a function within a class, it steps into the prototype. That's where it's sitting. Again, old semantics, newer syntax, right? That's how it worked before. They cleaned up that mess completely. So it works the way it's supposed to work under the hood, but when we write the code, we don't have to lose our hair, right? So that is basically the idea. So it is actually sitting within the prototype. That's where it is actually sitting. That's where it belongs. So we defined a function. Well, how do you define properties? I do have to say, this is one thing I actually like in JavaScript. How many of you program in Java here? Yeah, okay, it's quite a number of people. Java had a complete mess, isn't it? Java does not have properties. They tell you they have properties, and that's the biggest disappointment, isn't it? Because how do you use a property in JavaScript? You call get property name and you call set property name. You cannot just use the property directly in the case of Java. Well, how many of you program in C# over here? Oh, a few of us. You can all make fun of those Java programmers in the room, Scott and me included, right? Because in C# you truly have a property. And you can call a property in C#. How do you write a property in C#? You say object.property name. And behind the scenes, you use a getter and setter, but in the code you don't. Well, guess what? JavaScript properties are C# properties. That's what you get. So if you're not used to it, well, you get used to it. That's basically what it is. So how do we define a property? So let's say for a minute that I want to define something along the lines of travel distance. So I can say get. So, let's say traveled, let's say this is my traveled, and I'm going to write this as this is a method as we know. So I wrote this as traveled, and what am I going to do here? I'm going to say return this.km. That's what I'm going to return from this. I'm going to slowly work towards that. So what am I going to do now? I say car1.drive 10. As you know, if I say car1.kilometers, it's going to say 10 for me. But if I say traveled like this, it says 10. But I wrote a method called travel, but I don't want a method called travel, so what am I going to do? I'm going to put the word get in front of it. So what you're doing is you're turning that method into a property right now. And the minute you turn into a property, you no longer can use the parenthesis around it. That code will not work. It's an error, as you can see. But I remove the parenthesis right now and I run it. Notice it says 10. So you defined a property called traveled. So the traveled is a property. You put a get in front of it. You know, I like to use a word called annotation. So you're annotating the method with the get annotation, and as a result JavaScript says, oh, that's a property, not a method. So you cannot call it with the parenthesis, just call it like you call a variable, and I'm going to get that for you. So that becomes what's called a getter. Now on the other hand though, if you said car.traveled is equal to 20, well, we don't have a setter for this property. So when you run this, it fails. What does the error say? Car.traveled equals 20. Car is not, well, car1 rather, so pardon me. So car1, well, oh, wait a minute. Did I say there is no setter, right? Yeah, there's no setter. So if I ask for car1.km or traveled, notice that value, what is it, car1.travel, what does it say? It simply tells you 10 again. Now you may wonder and say, gosh, what happened over here? Well, this is the part I want to tell you, another feature of JavaScript. JavaScript is like my wife. And if I say something stupid, she just ignores me, right? And that is exactly what JavaScript does, right? She doesn't yell at me and say, you idiot, why do you say it? She just ignores me. And after a while, I'm like, okay, that doesn't work. I go back and behave after that. That's exactly the point here. Javas just ignored me saying, you idiot, I don't know what you're doing. You're calling a setter, it doesn't exist. It just ignored me. How many of you like code that quietly fails? Nobody does. Okay, one person does. You and I, 4 o'clock, will meet. So the rest of us, right? So the rest of us don't like code that quietly fails. I'm a fan of code that blows up on my face, right? Because if a code blows up on my face, I know when I write code, I'm wrong. You know, there's a benefit to knowing a code is wrong when you write it. Because the alternative is knowing the code is wrong when you put in production, right? I would rather know now than later. So how do you do that? I want you to note this down because it's a very important call you will make. Use strict. This is your friend. Always use strict. You know what a good news is? If you're going to use JavaScript modules, it's already done for you. Right? That is one big difference. Because this is the right way of writing code in JavaScript. What will happen if you use script? It's going to blow up on your face and say, there is no setter, don't call it. So when I run this code, notice you got the exception right there. It says, cannot set property traveled of car, which only has a getter. So in other words, if you put use strict, you will get an exception during runtime. If you don't get a strict, it runs in what I call my wife mode, right? So that's the easy way to remember it. So it's a strict mode versus it's going to just be quiet when you do something stupid. So you don't have a setter. But of course I would like to write a setter. So what am I going to do? I'm going to go back here and say set. And I will say traveled, and what am I going to specify over here? A value. So in this case, I'm going to say value, and this is going to be this.km is equal to value, and I'm going to set that value in here. So we wrote a getter, we also wrote a setter over here. Now, did you notice one thing though? A few minutes ago, I told you JavaScript has no overloading. And what did I just do? I overloaded. That is the beauty of the language. The minute you think you understood it, it'll change completely in front of you. So that is basically what it is. So there is rules, but what good are rules if there are no exceptions to the rules? Getters and setters are special, as you can see. So in this case, you pass only one value. You may wonder, what's going to happen if I don't put a value? It blows up on your face and says, you better give me a value. What if I put a value and it worked? What if I say something else? it blows up. You can only put one parameter to a setter. That's a requirement as well. Now, of course, if I come in here, notice what I could do. I could say minus 15. This is the way to keep a car new all the time. I know what you're thinking right there, right? So some people have tried this. They drive in reverse to see if the mileage goes down. That doesn't actually. But the point is, you don't want to be setting this to a negative value because that just simply sucks. So the beauty of this is you can go back and write code and you can say if value is less than 0, well, you can then say throw new error. And we can say found negative value, we will come burn your village, right? So you can do things like that. I always like that threatens the developers and they will never do this again. So in this case, of course, when you run the code, it says throw new error, found negative value, will come burn your village. So you can put exceptions for that too. But of course, you know that you can directly access the field, but properties just give you a little thin layer of protection on top of them. So we saw how to define properties. Hey, what about static fields? Now, I do have to say this is a disappointment in JavaScript, because how do you define a static field in a class? Well, remember first of all what we talked about a few minutes ago. You don't define fields within a class like the way you do in Java and C#. Well, if you're not going to define fields in a class, how can you then define a static field in a class? The short answer is the compiler could have done this for you, right? But they didn't. So this syntax is rather very ugly in my opinion. But how does it work? So what you can do here is, let's go back and simplify this code a little bit. So I'm going to say class car right in there, but I want to define a static field, so car dot, and you're going to put whatever the field is you want to put. For example, max fuel, let's say fuel level is equal to 100, let's say. So I could provide a value like this. So if I were to create a car, so constant car equal to new car, and I then say over here, print the car object. Well, notice the car object now does not really contain that static field because it doesn't belong to an instance, it belongs to the class itself. It's a class member. So of course, if we say car dot max fuel level, that becomes undefined. It's not part of any object, you know this. So, but on the other hand, I can put an uppercase C over there and notice the value of 100. That's how you define a static field for the class. So how do you define a static field? Just come out of the class and you just put that field right there and you just initialize the value for it. So not very elegant, but something you just have to get used to it. But on the other hand, of course, how do you define a static method of the class? Well, that's easy. Put the word static, right? Why do you put static here? Why don't you put static for a field? There is a rule that programming languages follow. They try very hard to be inconsistent. Because if a language is consistent, you will understand it. This is more fun. So they want to really be inconsistent, so we always scratch our head, and when you finish learning it, you feel accomplished, right? It's like, I know this. And then when you walk, people bow to you and say, this man knows JavaScript, this lady knows JavaScript. That's how you kind of get to that status. So you put a static over there. And I want to write a function here. What do I want to write over here? Whatever function I want to create in this case. So if I want to say here called, I'll just say foo for now. And I'm going to simply say called over here. Well, I can say a constant car is equal to new car, create an object. But if I say car.foo, that doesn't exist because again, it belongs to the class, not to an object. But if I put an uppercase C, you can see that it's called. But you know one thing from the older semantics, which is also the semantics that we use now, the foo doesn't belong to the prototype, the foo belongs to the function itself. So that is why you're able to say car.foo to call it. And just to illustrate the point, if you were to say car.prototype, dot foo, you can see that's undefined. It did not go in there, right? So it's not part of the prototype, it's part of the class. Just to illustrate the point, if I remove the word static, you can see that it's part of the prototype. Put the word static, it's not part of the prototype. So a static method is belonging to the class itself, not to the prototype of the class. Again, going back to the semantics, what belongs to the class belongs to the function, what belongs to the object sits inside the prototype of the object. That's the way it actually works. With all that said, we We talked about static methods. What about static properties? Oh yes, so you can go in here and define a get like that also. So in that case, if I were to return, let's say in this case, I'm going to simply say return 1. Well, then of course what you can do here is you can simply say car.foo. You can call it as a property because I said a static get over here. So that's a static property, not a static function. You cannot put a parenthesis around it to call it. So you can use a static property just like a static instance property. You can create that very nicely. You can create a getter and setter as well. Any questions before we move forward to the next topic here?
How do we create static constant?
Static constant, you said? Is that what you said?
Static constant.
There's no such thing. So when it's a member, it can be mutated. There is no constant of members. Only variables can be constant. Members cannot be constant in JavaScript. So you cannot really do that. No. You can try to hide it, right? But that's all you can do. But eventually, it can be mutated. JavaScript does not have that concept of private. JavaScript doesn't have a concept of constants in that sense. So you can change anything you want to. There's no such idea. So far, so good? What's the usage of what? Static. Have you used static in Java?
Yeah.
Same thing, right? It belongs to a class, not to an object. So if you use static in Java or C#, it's exactly the same idea. So you don't need an object to call it, it belongs to the class itself. So it's common to all the objects rather than being specific to one object of the class. Same idea, same exact concept. Yep. All right. So let's talk about one other interesting feature in JavaScript. When you look at this here, if I say class car, this is a class I created, and as you know, that is really the object, the class itself that we are using. This is called a class statement. So a class statement simply defines a class, and once you define the class, you can use it. But JavaScript also has a concept of class expression. Now, it may appear a little odd. Why would you have a class expression? Well, the reason is you can define a class like you do right here. But there are times in programming we do something called meta-programming. Meta-programming is where you create things on the fly based on the information you gather at runtime. So you could gather a bunch of properties, and when you gather this bunch of properties, you could say, gosh, look at all these properties I just got. Maybe I can create a class with these properties I just discovered. So this is called meta-programming. And meta-programming is a very powerful feature in a lot of languages, but what if you want to create a class on the fly? Well, if you're going to create a class on the fly, you didn't sit there and code a class at compile time. Classes come to life at runtime. And you know what? We do this all the time, isn't it? That's what we do. Humans do. We discover things. And when you discover things, you start classifying things you discover. A lot of things around us, new things are created. And that's exactly what you want to do here. So how does this work in that case? Well, I want to create a class, and I want to return a class to you at runtime. How does that really look like? So for this, let's create a function called create. So this function, I'm going to take baby steps and do this one step at a time. So I'm going to say return class, and I'm going to return a class to you. Now that looks a little odd, isn't it? I am saying you call create. You know what? Java programmers would love for me to use the word called class factory, because we love that word called factory, isn't it? Because the word factory sucks the life out of you. So we all use that. That's why I don't want to use that word over here, but it's a factory. It creates a class for you at that point. So what am I going to do here? When you call create, it gives you a new class, not an object, but it gives you a new class at this point. So what can I do? Then I can say, for example here, a constant class is equal to create. And if I print the class over here, that's a function. Does it make sense? Because you returned a class to me, not an object. Then I can say constant O1 equal to new class, and I can print out O1. What is that really, O1 rather? So what does that contain? contain, that's an object of that class we created dynamically. So I know this doesn't really mean much right now, but we can start putting more things onto it as we work through it. Like what? I'm going to come in here and say properties. So I'm going to pass some properties to this. So properties, and what kind of properties do I want to pass in here? I want to say create, and I'm going to say here, let's call this as wall, and let's call this as pages. So I'm giving two different properties called wall and pages. So I'm going to define something called wall and pages. And what do I want to call this? I'm going to call it as a book. So create is going to create a book on the fly. And then of course I can define the book, I can print the book right in here if you want to display that. I can create an object of book, we can call this as book 1. And of course in this case I can say book 1 and I can print it. So this is going to be a class of book. So what am I going to do within this class in that case? So to return a class, then I can say constructor. And what is a constructor going to take? It's going to take some properties, values if you will. And I'm going to pass these values exactly in the same order in which you pass the properties. So then what I can do here is I can say, properties. So we can say we can say constant property, so property of properties. So for every single property you give me, I can say this square bracket prop is equal to, oh darn it, I need the values, the index I, we'll get to that in just a minute. So I can say I comma properties of, and if you were in my morning talk, the syntax should make really good sense, and I can say entities, and you can get the entities from here, and then once you get the entities, I can get the I property. For the property, I can assign a value to it directly right in here. So how does that work? Once we remove the syntax errors over here, we'll see this working. So what does this provide for us? Let me check the error really quickly, and then we'll move forward. So what does this tell us? Oh, entries, right? So entries. So let's try that. So notice that we created an object. But how do I initialize an object now? I can say this is volume 2 and it's got 171 pages in this volume. So we created a book which is going to be volume number 2 and has got that many pages. And just to illustrate the point, let's go ahead and try this one more time. I'm going to say constant, we'll say t-shirt is equal to create. And what is the property? I'm going to say size, and then I'm going to say color. And then parenthesis, well, this is going to be a t-shirt object, so we can say this is going to be a t-shirt, so we'll say t-shirt, and then I can say output new t-shirt, and what is the size? I want to say medium is my size, and the color is blue color t-shirt. So you can see how we are able to create an object of a t-shirt on the fly. So the point really here is you can start creating classes on the fly, and that is useful for creating classes with what are called expressions. So those are called class expressions. So how do you know it's a statement versus expression? You put a return or assign to a variable, right? So if you don't assign it to a variable or return it, it's a statement. You assign it to a variable or you return it, it becomes an expression. So of course, when you're writing this, you can give a name for that as well. So in this case, I say X over here, that's a name it gives you, but it's still an expression. So this gives you a way to do very dynamic ways to create it, and the internal name in this case is X and so on, so we can create that very nicely. So far so good? All right, so that's basically what classes are. So what did we learn so far? The old semantics of classes is the new semantics of classes. How it behaved before is how it behaves now. No difference in how it works under the hood. Except you removed all the clutter and confusion. The syntax is streamlined. It's a lot easier to write. So it's not confusing when you write the code. It's easy to write it, easy to edit it. It is easy for developers to work with other people's code, and you don't need a silly library to do what can be done directly in the language. So far so good? But one thing you need to keep in mind, the old semantics is still the same semantics. That's something to keep in mind, right? So now let's go a little further. The next question is inheritance. So how do you define inheritance in JavaScript? Well, I want you to think about how it worked in the past. In the past, what you had is prototypal inheritance. So what does it mean by prototypal inheritance? I have a car. I'm going to the old syntax here, as you can see. And in the old syntax, I have a car. And then I'm going to say over here, car.miles equal to 0. Then I say car.prototype.drive is equal to, and it's a function taking a distance, this dot miles plus equal to distance, right? So this is the old syntax. Why am I talking about the old syntax? Because remember, the semantics of the old is the semantics of the new. So if you don't know how it worked before, you're not going to know how it works now. So it's important to keep that in mind. So now, I'm going to say a constant car1 equal to new car, and I output car1 dot miles. It is, what is the value of miles at this point? Pardon me, this is prototype, isn't it? It is 0. Then what am I going to do? Car1 dot drive 10, and then I'm going to say car1 dot miles. And what does it provide for me at this point when I run this code? It is 10. So that is all great, isn't it? So far so good. One more question. If I were to create a car, one more car, constant car2 is equal to new car. And now I'm going to ask the question, is car1 dot proto is equal to the car2 dot proto. There is a better syntax for accessing prototype, but I'm not going to use that at the moment. When you run it, notice it's true. So what does that tell you? That objects share their prototypes. Fair enough? So what is a prototype? Prototype is like a bag. Now, what is the purpose of a prototype? Now, here's an example. If you ask me, hey, so I have a nice backpack over there sitting in that corner. Now, you can ask me, Venkat, can I have change for 500 rupees? You know what? Absolutely. I'll reach into my wallet and I will give you change for 500 rupees, not a problem. But then you say, hey, Venkat, can I have change for $100? There is no reason for me to carry $100 with me. But I'm a nice guy. I'm not going to say no to you. I'm going to quietly walk over to my bag and I'm going to get you change for $100 and give it to you. So what does that mean? If an object doesn't have a property, it quietly reaches into its prototype. But you know what is so awesome about prototypes in JavaScript? Prototypes have prototypes. And they have prototypes, and they have prototypes, and they have prototypes, and they finally don't have prototypes. Yeah. And so it keeps going until it doesn't have any more. And that is basically how it works. Now, so if objects can have prototype, what's going to happen? So here's the question to ask. When you look at this code, notice very carefully the prototypes are equal. That means you create 7 objects of a class, all of them point to the same prototype, right? So if I create 2 objects of car, they share the prototype, right? Now, I went to the car 1, the miles is 0, I drove car 1, miles is 10. Now I'm going to say car 2.miles. Does that increase your blood pressure just a minute? Did you look at this and say, huh? The cars share a prototype, which means you drove car 1 10 miles, and you're like, damn, where's the car 2? Oh, it's over there, 10 miles away. Now, if this worked, you'll be angry. If this didn't work, you don't know how it works, right? So you're like, how does this work, right? So this is the beauty of programming. You're doomed if it works, and you're doomed if it doesn't work. Because if it works, you can explain why it works. If it doesn't work, you're not happy with it, right? So what do? So we got to understand how this works. Fair enough? Can you be my helper? Can you be my prototype? Okay. Oh, he said okay, just for the sake of records. What's your name, sir? Dinesh. Dinesh is my prototype. He seems like a nice guy. Are you a nice guy? He's very careful, maybe. Okay, I love it. So, Scott is a good friend of mine. We have known for each other for a long time. And Scott says, hey, Venkat, I'm in a rush right now. I got to go to the vending machine. Can I borrow $1 from you? You know what? Scott is a nice guy, just like you. I used to think he's maybe, but I know he's a nice guy. So I'm going to give him $1. So he goes away, gets the vending machine. An hour later, he comes back and says, that was a great help, Venkat. Here's the $1 back to you. And I got the $1 back. Now, a day goes by, and Scott is in a rush, and comes out and says, hey, Venkat, I'm in a rush right now. I need $100 from you. You know what? Absolutely. Scott has earned my respect and trust. Not a problem. So I open my wallet. I don't have 100 right now. Any ideas what I should do? Dinesh, Nice guy. So give me my $100 because he's my prototype. Didn't we all agree to it, right? So Dinesh gives me $100, and what am I doing? Here you go, Scott, and Scott takes $100. And a day goes by, Scott comes along and says, Venkat, you're a great help. Thanks for the $100. And he gives me the $100. What should I do with this $100? Keep it. I like it. Who said that? Keep it. Awesome. You're my new friend. I keep it. Does anyone have a problem with it? If you know how this works, you understood how prototypes work, right? So what did we learn just now, right? We learned that Dinesh is not happy, right? Which makes the rest of the room happy. And we also learned one more thing. Gets are deep, sets are shallow. That's what we just learned, isn't it? So we learned that gets are deep. So when Scott says, give me 100, I don't have 100, that's a get. Hey, get me 100, Venkat. I don't have 100, so what am I going to do? Go to Dinesh. If Dinesh doesn't have money, what happens? He's got a Swiss bank behind him. So it's never a problem, isn't it? So he's going to give me the money. But sets are shallow. So when he comes and gives me the $100, I keep it. Sorry, right? And that is exactly how JavaScript works. How do you prove it? Well, let's prove it. Notice what I'm going to do here. Okay, first of all, run this. Thank goodness. That is a 0, not a 10. But how do we know that it's actually doing that? So to understand this, let's go back and try this. So I'm going to say output car1 dot get own property. And I'm going to ask for the property called miles. So get own property on the object, right? So object. So get own property on car1. We're going to ask for miles. Get own property, I think. Sorry, has own property. Pardon me. So car1 has own property called miles. And notice it says false because it doesn't have its own property. You come to me and say, hey, Venkat, do you have $100? I don't. But you say, give me 100. Guess what? I'm going to give you 100. Why? Because I reach into Dinesh's wallet and give it to you, right? That's what I'm doing. On the other hand, you say car1 dot drive 10. And now you ask the question, car1 has own properties. Notice the difference. You went from false to true. And that is because sets are shallow. Does it make sense? Now, why am I talking about the old stuff? This is exactly how inheritance works in the new syntax. Syntax is new. Semantics is the same. If you don't understand the old semantics, you're going to come home bruised. And you're going to say, this JavaScript sucks because I am using it and it's misbehaving. You know what? It is not misbehaving. It's been behaving the same way all along. This is a very powerful concept. In fact, I would argue this is superior than class-based inheritance. Because Java's class-based inheritance smells. Because inheritance is static in Java. What does that mean? Once you inherit from a class, you're stuck with it. Not so in JavaScript. Inheritance is dynamic in JavaScript. You can change what you refer to at runtime. And that is like, you can have one parent for weekdays who are strict, and one parent for weekends who are very rich. That's a great idea, isn't it? That's called true inheritance, right? So you can just switch between them. And I used to do that when I was a kid. I used to have multiple parents, right? When my parents were really helpful for me, I'll have them. Otherwise, my uncles and aunts would become my parent for the weekend. That always worked really nicely. And you can just switch dynamically. That's what it happens in this case, right? So that becomes really effective way to do it. Well, the point really is, this is exactly how the new syntax works. So inheriting from a class is exactly the same. So let's go ahead and try this. Class, and I'm going to say person. And what does a person contain? Constructor contains. So the constructor says first, comma, last. And I'm going to simply set this to, over here, I'm going to simply say this dot first is equal to first, and we will say this dot last is equal to, let's say last. So then I say class, cool person, and extends person. Stop right there for a minute. Extends. What in the world that is? They decided they want to use the Java syntax. But when you look at that word extends, you got to keep one thing in mind. This is not class-based inheritance. What is this? This is prototypal inheritance. It looks like a duck, but it's a chicken. right? So you got to keep that in mind. And this is the part I'm not happy with, because they make the syntax so much like Java, it gives you an illusion. And people tell me, oh, now we have inheritance in JavaScript. No, we don't. We have had inheritance forever, and it's called prototypal inheritance. You know what? Had they said class school person prototypes person, what would have happened? We would have understood what was happening. So they said, no, 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 no. We'll call it extends because nobody has a clue what we are doing. So this is not class-based inheritance, it's prototypal inheritance. That's what it really is. So what's happening at this point? At this point, the cool person's prototype refers to the person class. That's what it's really doing at that runtime. If you want to just take a peek at it, if you say cool person dot prototype and ask for that, and if you ask for what's behind it, so let's go prototype, well, that's undefined. So this is going to be one level below, and you can ask for the prototype of the object, and internally it's going to be a person behind this. They're hiding it one level below, but that's what it really is. It's going to contain the person object. So then what do? And one more thing, I'm going to say constant. We'll call it as P1 equal to cool person, and we will say Alan comma Turing right here. We can agree he's the coolest person, isn't it? And P1, and that worked. Now comes a really good news. I love this part. Those who program in Java and C#, you know one thing, right? If you inherit from a class, what do you have to do? You have to write the constructor. And in the constructor, what do? You say super or base. What is that called? Punishment, right? Because I'm not doing anything new. And the compiler says, I want you to write that for me. And you're like, but I'm not doing anything new. Are you done yet? I'm waiting for you. So I always ask this question, do you work for the compiler? Or does the compiler work for you, right? When I program in Java and C#, I work for the compiler. And the compiler comes to me and says, are you done with it yet? No, I'm still working. Okay, finish that, I'm going to go to lunch and I'll come back, right? And I'm sitting and coding. JavaScript is like, you know what, you're not doing anything special, isn't it? No, then don't write it. I'll write one for you. So if you don't write a constructor, they write one for you. And they call the base automatically for you. You don't have to do anything. But of course, if you do want to write a constructor, you're most welcome to write one. So in this case, I'm going to go here and say constructor. And what am I going to do? First comma last. And then I'm going to say over here, called. So called over here. And then I'm going to say super. And I'm going to say first comma last over here. And notice how that beautifully worked at that point. You're not required to write one. You can just write this and be done with it. And then you look at this and say, oh, Venkat, you said super, but I am remembering my Java skills, and in Java, super has to be the very first call. Yeah? Yeah, absolutely, that's true in JavaScript also. Super has to be the very first call. But the language says, we are friends, come on. If you're not doing anything stupid, I shouldn't yell at you. So if you're not touching the current object, you don't have to call super as the first one. And this is a little trick here. So if I go here and say, this dot index is equal to 4, or 10, whatever that is, right? So notice now, the compiler is not happy with me. Why? Because you touched the this before you call super. So the compiler is very pragmatic, isn't it? It doesn't tell you, super has to be the first one. It says, don't do anything with the object until you call super. Oh, great. So I'm going to move this down here, and you and the compiler are best friends now, as you can see, right? You don't have to really do anything different. So that's basically the rule of the languages. You don't touch the current object until you call super, but you can do other stuff if you really want to. That's perfectly fine. So little things like that can be really nice to have. So that's basically an example of how you can call that. But of course, you can also write functions over here. So toString, and what can I do here? I can say return a cool person, and then I can then say, let's use a newer syntax. So cool person, and then $super.toString, and I can call the base method after that, and you can see that, well, let's put a little cool person with an exclamation, and then call into it. So you can say p1.toString, just to illustrate the point, you're calling that and into the base class. Similarly, you can come and use the toString over here, and what does that do? It simply says return. We'll say first, and then we'll say last over here, and as a result, of course, this dot, right? So this dot first and this dot last, and when you run this, you can say Alan Turing right there and prints it. So you can use the super, as you can see in here, to call the base methods. So very much, it begins to feel like writing Java code, but you got to constantly keep in mind, this is prototypal inheritance, not class-based inheritance. So what does that really mean? It means that this is part of the prototype of the object, and so as a result, you can go to the cool person class. So p1 dot proto, actually, let's do this the right way. So how do you get the prototype in a more civilized way? You can say object dot get proto type of, and then P1, and you can get the prototype of that object, and you can then go back and say object.get prototype of the prototype, and you can get that. Did you notice that? That's a person at this point. Why? Because it's prototypal inheritance, not your class-based inheritance. And then if you want to really, really mess with it, you can go change the prototype of the cool person now, and you can make it point to something else at runtime. It's old semantics is still true. Exactly what you had before is exactly what you have now as well. So that's basically how that works. So you can write a constructor. I showed you how to do that. We saw the default constructor. I showed you that as well. And you can override methods. I showed you that also. So far so good? All right. So with all that said, the last question is, what are decorators? Now, decorators are not quite implemented in the language. So this is a spec. This is the beauty of JavaScript, right? They would do stuff and nobody implements it. They're like, doesn't matter, this is a new spec. And then you suddenly look at Angular. And what do you do in Angular? You say at component, and then you are using decorator in Angular. And then you're like, gosh, how could Angular do this if you don't have this implemented in the language, right? And the answer to that question is very simple, tools like Babel. So tools like Babel will compile your newer syntax into older syntax. Now, why is tools like Babel very important? The reason is there's a problem here, right? You have newer syntax in JavaScript. Now, the newer syntax in JavaScript, does anyone know which browser supports all the features of the new version of JavaScript? No. How many of you use, oh my God, I'm throwing a blank at the moment. Sorry? You could use that, but the browser name, oh my gosh, anyway, it'll come to me. So browsers support JavaScript, but they support to different degree, different level, right? Depending on which browser version you are using, they all kind of vary from time to time. And there are very few browsers that actually support it. I'm throwing a blank at the moment, but very few browsers actually support all the features of the language. Now, the problem is, if you're using a browser, it supports some features and not other features. And you're wondering, when will all the browsers support all the features of JavaScript? I've got a good news for you. Every single browser will be 100% Java compliant within the next 20 years. And in the meantime, though, we still have to write code and get it released, isn't it? So how do we do that? Well, the answer to that question is, this is where tools like Babel come in. So tools like Babel will compile your new JavaScript to old JavaScript, so most of the browsers will support it, right? And of course, when it doesn't, you have polyfills to substitute. But decorators are implemented exactly the same way. So how do decorators actually work? So if you're writing code in Angular, for example, you would do something like my component, right? You would be writing your own component. And then what would you do in Angular? You would say component, and then you would specify in here something like selector, and then you would say my selector, and then you would say something like template URL, and then you would specify some, whatever dot HTML and things like that. So the question is, how do these things actually work? So there is actually no magic here. So what actually happens is, Babel will compile your decorator into a function. That's what it really does. Where that function actually is a factory function. So literally what they do in that function is, they will take your class and they will add stuff to the prototype of the class and return the class to you. So it's just a function, it's a factory. Hey, I wrote a class expression earlier, right? It's a very similar idea, except rather than creating something new, they take your existing class and they inject the behavior into it by adding things into the prototype, and they return to you. And if you have a lot of patience, what you can do is you can take your Angular code, or wherever you use annotations, rather decorators. Java annotations are JavaScript decorators, right? Because they never want to call the same name because we will understand it otherwise. So this is basically decorators. So what do? So compile with Babel, and then you open your source code, the one produced by Babel, and take a look at what's going on. And what you're going to see is functions. And these functions will take your class myComponent and inject into it a selector property and a template URL property, and then return that class to you. And then when you do a new on that class, it contains the properties for you. So that's exactly how decorators work, is at least right now. When it is supported by all the browsers and Node and etc., then this will become a first-class citizen in the language, but we are far away from that as of now, and eventually that's the way it's going to work. So what do decorators do? Decorators are useful to give a property to color, to enhance a particular class. Now this is a very different approach than using inheritance. If you're using inheritance, the React way of doing things, what do you do in React? You say class myComponent extends component. Well, that's what you do in React. In Angular you don't do extends, because they do injection rather than extension. It's just a different way of thinking, right? There is no one right or one wrong. It's just how you want to work with it. So they inject properties into your class using decorators rather than using inheritance. That's basically the idea behind this. And then of course that object comes to have that particular property. So to summarize what we talked about over here, we saw how JavaScript has evolved. So to summarize, a couple of things to quickly mention. The old semantics still rules. Everything worked in the past works the same exact way now. What is different is much better syntax. But as you're using the newer syntax, get very happy, get very comfortable with it, but don't lose sight of the fact that it's the old semantics with the newer syntax, right? As long as we can remember the semantics, syntax becomes natural, we can benefit from that. Hope that was useful. Thank you.